The lowest point this graph gets is right here. It'll keep getting there, but that's the lowest point it gets to. This is the highest point it gets to. The lowest point it gets to is a -1. So we're going to go from -1 to the highest point it gets to is 1. Now, we have to talk a little bit of semantics on this. I used parentheses on infinity because we'll never get there. I can't count to infinity, nor can either of you probably. However, this graph does include -1. I can get -1 as an output. If you can get that value, you use a bracket. So it's bracket -1, comma, 1 bracket. Now we have some terminology we have to get done. First one is sinusoidal axis. The sinusoidal axis is just the line that runs right smack dab through the middle of your graph. So if you look at my red dotted line, that is called your sinusoidal axis. I know it's a fun word. That sinusoidal axis will always be at 0 unless your graph gets shifted up or down. So most of the time, your sinusoidal axis is going to remain there unless it gets shifted up or down. The sinusoidal axis goes with it. So your sinusoidal axis, you'll hear me say that more, is that one that goes smack through the middle of your graph. The next thing is amplitude. It is the distance between the sinusoidal axis and the max or min. The way I look at it is, so we have a sine graph that goes from here to here. Your amplitude is half that distance from your lowest to highest. Your amplitude, I'll do it in purple, is going to be this distance right here. And that distance is 1. I'm also going to note that amplitude is a distance. It must be positive. So my amplitude is 1 here and still 1 down here. It's basically how high is one of your mounds. This case, it's 1. Our amplitude equals 1. And I'll also put that this must be positive. It's always positive because it's a distance. And I say that because sometimes people measure this one and they're like, oh, it's -1. It is not. It's still +1 even if I measure it down here. The last thing we have is the period. The period is the length of a complete cycle. A complete cycle is when it starts repeating itself. So what I have graphed here is one cycle. The dashed lines would be another cycle. So the period is how long does it take to complete one full cycle from start to repeating again. So this right here is the period. And in this case, we go from 0 all the way to 2 pi. So the period's actually going to be 2 pi. That could be a length. Pi is a number. It's just like me saying it's 6.24. We're going to call it 2 pi. So in this case, the period is 2 pi. So the key things we need to note, I'm going to put those over here. Our amplitude is 1, and the period is 2 pi. So one cycle. That's sine. Cosine, we're going to have to shortcut a little bit just for the time. Do we have questions? Sorry. Are you good? Okay. For cosine, if we did the exact same stuff, we don't really have time to go through all of that. I'm just going to show you the graph. If you graph the cosine of 0, you'd get out 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And finally, the cosine of 2 pi is back up to 1. It's pretty much the same except it's shifted over. Read.
So can we always assume that the domain's infinite in both directions?
It will always be. And I'm going to show you a different way to write it that might save you some. So if I was going to connect this stuff, this is a bottom mound, and these two things are kind of half mounds. That if I was to continue to draw, it would look something like that. If I was to continue to draw, we'd have something like that. Because if you put in the cosine of 0, you get out a positive 1. It's just the values that if we plug it in, we'd get it out. Kind of like here, we plugged in the sine of 0, and we got out 0. 0 pairs with 1. So sine and cosine are opposites of each other, so they get shifted over. Your job is to remember which one starts at 1 and which one starts at 0. Otherwise, they're just mounds for both of them. And we'll practice it enough that as long as you try it, this won't be hard. All right, so as said, the domain is all real numbers. I'm going to put another way to do that. You could put a boldface R. It's just an R with kind of two lines. This is how they use the bold letters. That stands for all real numbers. That stands for negative infinity to positive infinity. Yeah?
So are we always going to be using pi or 2 pi?
For today.
Okay.
For today. You're good for today. All right, what's the range of this one? How low to how high does this graph go? Same as the other one. It goes down to -1 and it goes up to 1. So our range will be -1 to 1.
So can you do negative infinity for domain, or you can do that?
Yes, your choice. I have it in both ways on the answer key as well.
Brackets around the R. Is that still correct?
We do not want to put brackets around there. That means it includes all negative numbers and all positive numbers, which we can't count to. You're also making a set within a set. Just don't. I'm not going to take points off, but just don't. All right, we learned amplitude is basically that halfway point up to the top. What's the amplitude of this one? 1. The amplitude is still 1. What's the period of this one? How long does it take till I start doing dashed lines because I'm repeating it?
2 pi.
It's still 2 pi. Once again, I'm going on the memory that you guys have done this before, so it goes through quick. If you're lost, you need to come get help on this stuff. Today is just basic graphing stuff, but if you don't get it, you don't get it. Come get help. All right. What we just drew is called the fundamental cycle. The fundamental cycle is from 0 to whenever that period ends. I don't talk much about the fundamental cycle. We just are going to keep doing the same graph every single time. We just start with that graph and we shift it and stuff. Here's the fundamental cycle of cosine. Now, graphs, aren't just going to be sine of x and cosine of x. We're going to have big ones that get shifted up, down, flipped, and stuff. So we're going to start out small today. But just know any sine function can be rewritten in this form. And I'd like you to add something to this. Put a bracket to the left of B and a bracket after C. That makes more sense to me. Because that means you're taking the sine of all of this stuff. Today we're just going to talk about 2 letters. That's it. Just 2 letters today. We'll do the other 2 letters tomorrow. No, not tomorrow. Thursday or Friday, whenever I see you next. Thursday. Friday. Whew. So we got to get through this. Okay. We're going to talk about the letters A and the letter C from there. A is that number that goes out front. You have it attached to your sign as that multiplication. That is in charge of your amplitude. It can also flip your graph if it's negative. So it changes your amplitude, and it can flip your graph if it's negative. If I have 3 times sine x, and I ask you for your amplitude, remember, amplitude has to be positive, so it's going to be just 3. Amplitude equals 3. You just snag this number and you say that's my amplitude. If I ask for the period today, you're always going to put 2 pi. Tomorrow that's going to change, but for today, it's just 2 pi. You don't have to worry about it. The period's going to take 2 pi to cycle through. So that means if you're labeling your x-axis, we're going to label them like we did on the other side. We're going to go count out 4 tick marks. 1, 2, 3, 4, and we're going to put that 2 pi there. What's half of 2 pi? Pi. So we're going to go here and put pi, because that's half the distance. What's half of pi? We're going to put pi over 2 here. We have 1, 2, 3 pi over 2, so this is going to be 3 pi over 2. Or you're just getting the hang of writing those 4 numbers. Oh, over 2, yeah. Our amplitude is no longer 1, it is 3. That means our graph has to go all the way up to 3 and down to -3. So when I label my y-axis, we're going to go 1, 2, 3. And we're going to go down -1, -2, -3. Now, here's my advice, especially for early graphing. Use your pencil and make it really light. We're going to graph a normal sine function, just a normal one. So with no changes, I'm going to graph sine x. Now, from the other page, sine x starts at 0, 0. I'm going to use a different color. I'm going to use light pink. So I'm at 0, 0. Sine goes up to 1, down to 0, down to -1, and back to 0. So this is just regular sine. I would just write really light because that's not your answer. That right there is just plain old sine x. I didn't miss anything, did I? No. So that's your plain old just sine x. We're supposed to graph 3 sine x. So that means our amplitude needs to get stretched. Our graph needs to get stretched. Anything on the sinusoidal axis remains. I'm going to go ahead and use, I don't know, maybe bluish. Anything on the sinusoidal axis stays the same. So these 3 points will stay the same. Everything else gets stretched to 3 and -3. So my amplitude is 3. So rather than going up to 1, I'm going to go all the way up to 3. Instead of going down to -1, I'm going to go all the way down to -3. And we keep those as bumps. And now we should note to me when grading your test that this is my final graph. So I'm going to put that as 3 sine x.
This is not bad.
Not yet. I'll get harder. Don't worry about that.
End of last year.
What was that?
This is the very end of last year.
Yeah. So we're basically kicking off where we ended there. Okay, our next one is -2 cosine of x. Amplitude cannot be negative. So what we're going to do is we're going to say, okay, there's a 2 in front of it. We know it's negative. That's going to cause it to flip. So maybe I'll note that negative is going to cause it to flip. But the 2 itself is your amplitude. Your amplitude is a positive 2. Always positive. And the period is going to be 2 pi because I just told you today that's all it's going to be today. So we're going to go ahead and label our x-axis as pi over 2, 3 pi over 2, nope, yep, and 2 pi.
Wouldn't it be pi over 2 then?
Yes, that's what I messed up in my head. It'd be pi over 2. I knew something seemed off. Pi, 3 pi over 2, and then 2 pi. Our amplitude this time is only 2. So that means I don't have to go all the way up to 3. I do have marks for it, but we just have to go 1, 2. I can go underneath here and it'd be -1, -2. Now I'm going to take that pink color and I'm going to graph regular cosine. Sine starts at 0, 0. Cosine starts at 0, 1. So I'm going to put a point at 0, 1. I'm going to go to the sinusoidal axis. I'm going to go 1 below it. I'm going to go back to the sinusoidal axis, and I'll go 1 above it. Remember, this is not my final answer. I'll even tick this to say this is just scratch work. That is just plain Jane cosine x. Now, if I go too far with this one, let me know. I'm going to do 2 steps in 1. We know the amplitude is 2, so anytime we're up here, we have to go to 2. But do you see that negative sign in front of it? Instead of going up to +2, we're going to go down to -2. So basically, I'm coming up here, and I'm bringing it down to -2. I guess I could draw that. Bless you. So I go up here, and I bring it all the way down to -2. The nice thing is if you know the amplitude, and you know how cosine works, our next value is going to go back to the sinusoidal axis. Then it's going to go up to positive 2, back to the sinusoidal axis, and down to negative 2. So you're going to see this looks just like regular cosine, except it's flipped and stretched. And then I'll put a little arrow to it and say, you know what, that's negative 2 cosine x. Questions on amplitude? What's the domain of both of these? Negative infinity to positive infinity. I forgot that I added these. So we can either put all real numbers or we can put negative infinity to positive infinity. I'm going to put the all real numbers on that one. This is just, it's called a bold-faced R. It's an R with two kind of side things. So basically draw an R and put an extra line on it. This graph goes to negative 3 now, doesn't it? And up to 3. That's going to change your range to negative 3 to 3 with brackets. Let's not be texting or anything. Phone should be away. All right, this one, our lowest one is negative 2, and it goes up to positive 2. So our range will be negative 2 to positive 2. All right, that's domain and range. I should be able to get through all this in 5 minutes as long as we hurry up. All right, our next thing is called a phase shift. That's your letter C. That's inside the parentheses. Here's the thing about phase shifts. It goes the opposite direction you think. It's going to go right if you see x minus a number. It's going to go left if it's x plus a number. So it kind of goes the opposite direction. Left, right goes the opposite direction of what you see. So my example is I have sine of x plus pi over 2. What number's in front of sine? 1 is there. So that means our amplitude is 1. Our period is still 2 pi. However, we're going to shift this. And because it's positive, we're going to go left. So we're going to go left pi over 2 units. I labeled your x and basically your y-axis because it has an amplitude of 1, so we just have to go up to 1 and negative 1. We're going to graph a regular, I'm going to scratch that if you already hurried up. I'm going to make this a little smaller. It's too stretched. So if you can look, I put little tick marks in between just so I'm not going way up and way down. All right, a regular sine graph starts at 0, 0. It goes up 1, back to the sinusoidal axis, down to negative 1, back to our sinusoidal axis. So my pink ones are just plain old Jane sine. Now, if I want to go left pi over 2, all you have to do is move the points left pi over 2 units. And I'm going to start with this guy. I'm going to take that guy and I'm going to shift it left pi over 2 units. And do that to all of them. Left pi over 2, left pi over 2, left pi over 2, left pi over 2, and that's it. That is our sine of x plus pi over 2. So my advice is just move this one and see how far it moved, and then just move them all that same distance. That way you're not constantly subtracting pi over 2 from stuff. So just see how far it moved and move everything that exact same distance. Real quick, what's the domain of this one? All real numbers. Thank you. Those are going to be really hard. Range, did I change the amplitude?
No.
I didn't shift it up or down, so it should be negative 1 to 1, right?
Yes.
Negative 1 to 1. Try to put curves on it. Try not to have like straight arrows. I don't like those. It's a personal thing. It's kind of like if you did x squared and you just drew a v. It's a different graph. All right, what's the amplitude of sine of x minus pi over 6?
1.
It is 1 because there's a 1 out front of it. What's the period all today? 2 pi. Are we getting shifted left or right?
Right.
Right. It's negative though, so shouldn't it go left?
No.
Oh, it goes opposite. So if it's inside the parentheses, it goes the opposite direction you think. So it's going to go right pi over 6. We're going to start by just doing a regular sine graph. If you're following along with me, sine graphs are going to be boring. It just starts at 0, 0, up 1, back, down -1, back. Here's where it gets a little more difficult. Did I label pi over 6 on here? No. So here's where we're going to use a little creativity. Is pi over 6 bigger or smaller than pi over 2? It's smaller. I really just need you to kind of estimate on where it's going to be. So if you remember from our unit circle, it goes pi over 6, pi over 4, pi over 3. So if I'm shifting all of these right pi over 6, I just need to kind of bump them over just a little bit. That's a terrible color. Let's use red. So you notice how my first point just moves a little bit? They're all going to just move that little bit. So I'll move this one just that little bit. Move this one just that little bit. A little bit. A little bit. Connect our points with nice curves. Make sure Mr. Pavia knows what your answer is, and it's the red one.
Nice.
Our domain should be all real numbers.
So that's why kind of like drawing the sample one's helpful.
Oh, I'm gonna stress, if you struggle with these, draw just a basic one first and use that one for everything else. And then our range is going to be from -1 to 1. You're going to see tomorrow we're going to start adding up, down, and we'll stretch it a little bit. But if you could draw the basic graph every single time, transformations are not that hard. It's just left, right, up, down, change your amplitude. Yes?
So